Hi everyone, hope you are doing good. Today I'm going to start new chapter, chapter 11. In this chapter, we are going to talk about one population proportion. Section 11.1. This is specifically based on confidence intervals for one population mean. Okay, uh, if you remember in chapter 7, we discussed of the sampling distribution of the sample means. At the end of that chapter 7, you learned that if we have our population is normal or approximately normal, if our sample size is large enough, then we can get our mean of that sample means equals to the population mean, and standard error sigma x bar equals to population standard deviation divided by square root of n. Uh, Population proportion we denote by simple p. So this population proportion we didn't define like number of successes divided by population size. See, simple p equals capital X divided by capital N. This capital X mean number of successes in the population, and this capital N means population size. So we can represent this fraction or this proportion like a percentage. If you multiply this by 100, you can get a percentage value. So it doesn't matter. But the problem is it is really hard to calculate because of this n. Most of the time our population is really big. So at that time we don't know what is the size of our population. So we have a problem, right? We cannot calculate this P population proportion without having a knowledge of this guy. So to overcome this problem, we are going to estimate our population proportion. So we overcome that problem by considering sample proportion. Instead of population proportion, we are taking sample proportion, which means simple p hat. That's what we call for this sample proportion. Okay, so in this sample proportion, same thing as I denote last time, it depends on x and n. Here p hat is equal to number of successes in our sample divided by number of elements in the sample or sample size. So here letters are capital. See, simple x over simple n. Number of successes in my sample divided by sample size. So we denote this proportion by using simple p hat. So simple p hat mean sample proportion. Okay, so we use this sample proportion to estimate population proportion. We use this p hat to estimate p. Okay, what is p? Capital X over capital N, which means number of successes in our population divided by population size. Since we cannot calculate that, we overcome that problem using sample proportion. Okay, so in this case the sample proportion p hat is the point estimator, and this p is the parameter. Okay, so this is the p hat, this is the point estimator. This is what we can calculate. Okay, let's see this. What is this guy? What is this sample proportion looks like? Okay, first let's try to get its mean p hat, mean of p hat. So Mean of p hat we can simply represent by p. It is same as the population proportion. It is same as the population proportion. Okay, so standard deviation of p hat is sigma p hat, which is the standard deviation of p hat, equals under square root p times 1 minus p over n. So the simple p is this p, mean of p hat. Okay, how do you calculate this simple p? Using capital X divided by capital N. Successes in population divided by population size. Okay, so since you know the formula to calculate mean of p hat and standard deviation of p hat easily, we can talk about the distribution of p hat. P hat is unbiased estimator for population proportion, which means simple p. See, mean of p hat, we denote by mu p hat, is equals to p, population proportion. Here, in this case, don't mix these p hat and p. Okay, always p hat mean sample proportion, and p, simple p without a hat, denote the population proportion. Okay, so some problems they will give you what is p, some problems they may give you like number of successes in the population and population size, so easily you can calculate simple p. Okay, okay, uh, there are a few things you should know about this proportion, sample proportion p hat. If you need to calculate this p hat and you have to deal with this kind of problems, first you should check whether this p satisfies this, which means n times p, this n simple n sample size, it is sample size, multiply by your simple p, population proportion, should be greater than or equal 5, and the same time sample size times 1 minus p should be greater than or equal 5. Okay, before you go into your problem, you have to check this. If your problem violates this condition, then you cannot use this sample proportion technique. Okay, so in the first place you should check this. If this is okay, then you can say that okay, my p hat is approximately normal, it doesn't matter normal or approximately normal, with mean p and standard deviation under square root p times 1 minus p over n, same thing we mentioned here. Okay, so my p hat, which means sample proportion, has a approximately normal distribution with mean p and standard deviation this one. Okay, okay, if you remember this confidence interval for one population case we discussed in few chapters back, if I remember you this one, confidence interval we denote by CI, confidence interval. So confidence interval is point estimate plus or minus margin of error. Okay, point estimator plus or minus margin of error. Or at the same time, if you want, you can calculate it by using another way like point estimator plus or minus without having this margin of error. You can replace this margin of error by using C table value times standard error of the point estimator. We have done these things. Okay, so if you don't remember those stuff, please check it. Okay, because you will need confidence interval. That's what we are doing in this section, section 11.1, confidence intervals for one population mean. Okay, so only a new thing is this one population proportion. I'm sorry, we are doing confidence intervals for one population proportion. So only new thing is this guy, population proportion. Okay, uh, table value, this table value, C table value, it depends on the confidence level, which means alpha. Okay, okay. uh, Before we start the questions or problems using this population proportion, there are actually two specific things, two specific assumptions we made. We believe that okay, these two are okay if we need to use our population proportion technique. First assumption is simple random sample. We have simple random samples. Okay, then in that simple random sample, our sample size n times this p hat, or simply you can say okay, this is p, doesn't matter, greater than or equal 5, and n times 1 minus p greater than or equal 5. Both should be satisfied. Okay, then you can calculate this confidence interval for population proportion by using this formula, p hat plus or minus c alpha over 2 square root p hat times 1 minus p hat over n. Simply, this p hat mean uh, sample population proportion. Okay, sample population proportion. Clear? Okay, then margin of error. If you remember, if we find the confidence interval using this formula, this part after the plus or minus right hand side part we consider as a margin of error. Okay, let me show that using another color. Okay, this part we denote the margin of error. Okay, which means here margin of error, margin of error for p is equal to c over c alpha over 2 and square root p hat 1 minus p over n. Okay, okay. I have mentioned few uh, not specific few steps. These are mandatory steps. Okay, so if you follow these steps, it's okay. Okay, then you will get all the points because these are the necessary steps. Okay, so try to follow these steps. There are 6 steps, but you don't need to write your answer like step 1, step 2. No, just write your answer, but make sure that you have followed these steps. Okay, okay, we are going to find the confidence intervals for one population portion, one population proportion. Okay, so uh, first check the assumptions. Only thing you need to check is this assumption. So the simple random sample one, uh, it doesn't matter, it's always true for your case. Okay, so you have to check your sample size times your p hat sample proportion greater than or equals 5, and n times 1 minus p greater than or equal 5. Okay, see p hat you can calculate by using successes in your sample divided by sample size, which means simply sample proportion. Okay, so second step, find the significant level alpha, then take alpha over 2 and find the c alpha over 2. Okay, c alpha 2 over 2 find by using c table. Okay, uh, calculate the margin of error e. What is margin of error? that C alpha over 2 times square root of P times 1 minus P over N, this part. So you know what is P hat from step number 1. So you know what is simple N from step number 1, and this value C alpha over 2 from step number 2. Okay, so you can calculate this margin of error E. Then you can easily calculate the confidence interval. This P hat, which means this value or this value P hat, left side value is minus your margin of error, comma, right hand side value is P hat plus E, or simply you can say P hat plus or minus E. Okay, so left hand value and right hand value, because this is the interval, there should be a minimum value and maximum value. Okay, so at the end you should write the interpretation according to your question. Okay, okay, let's see, let's try to do this example. I'll use a pen. Okay, when you go through this question, you can gather all the necessary information. Okay, I'm not going to read the question line by line, but I'll show you what are the necessary information. See, 1000 American adults. So here they have given you should use 1000 American adults. We'll ask among other things, once a week 38%. Yes, which means 38% is what? 38% is the sample population, sample proportion, P hat. So this is your, this is going to be your P hat. Okay, so this is your this is your simple N, and they have given interpret at 95 confidence interval. So 95 confidence interval for the population P. Okay, okay, let's see. First you have to calculate your simple P hat. You know that value they have given, it is 38%. 38%, which means 0.38. So please don't write P hat equals 38%. Okay, sorry, don't write P hat equals to 38%. No, P hat equals to 0.38. Clear? Okay, P hat should be a proportion value. Okay, okay, first you need to check this value greater than 5 or this value and this value greater than 5. Here P hat equals to 0.38. So simple N equals to how much? 1000. So 1000 times which means this one here. This is definitely greater than 5. And also you have to check this guy. That is exactly you can see that value is greater than 5. Okay, then step number 1 done. Now step number 2, find the significant level alpha. Find the alpha. They have given the confidence level. Okay, this 95 is the confidence level. Don't mix them up, it is not the alpha. So if you need to get the alpha, definitely you should subtract that value from 1. 1 minus 95%, which means 0.95. Okay, is your alpha. So alpha value is 0.05. Now you have to get alpha over 2, okay, which means 0.025. Then go to the C table and get this value, C alpha over 2. So that value is 1.96. Okay, step number 2 done. Now step number 3, use your formula to calculate the margin of error. We denote by E, but C alpha over 2 under square root of P times 1 minus P over N. So you know what is C alpha over 2, you know what is P hat, you know what is simple N. Plug those values as mentioned here and calculate your simple you are calculate to a capital E, margin of error. Done. Now step number 4, calculate the confidence interval. Lower bound p hat minus E is this value. P hat is 0.38 minus this value E, it is 0.03. Upper bound p hat plus E, 0.38 plus 0.03. So 95 confidence interval for population proportion you can write down like this: lower bound, upper bound. Okay, so always a lower value for the left side, upper value for the right hand side. Okay, step number 4. No, this should be step number, yeah, that is step number 4, because we skipped the first step here. See how to calculate this stuff, and this should be, oh sorry, this should be what happened, okay, this one, right? Sorry, this should be the step number 6. So at the end you have to write the interpretation according to a problem. So what they asked to find you 95 confidence interval, the population proportion. So you have to write it, okay, we have 95 confidence that the proportion of what they ask, portion of drinking alcoholic beverage of American adults lie in between the values. You figure it out. Okay, values which you have figured it out. Okay, okay. Example number 2. Let's see. A poll of 1010. Okay, I'll circle the important facts. Okay, those surveyed 140 had experience what they have mentioned, and find and interpret 90% confidence interval. So 90% confidence level they have given. So using that you have to figure it out what is the alpha. Okay, so using this you can figure it out. Okay, alpha is equals to 1 minus 0 point, sorry, 0.9. Oh, I'm sorry. Okay, 0.9. Okay, so alpha is 1 minus 0.9. They have given 90%, so alpha, we figure it out. Okay, what is this n is US adults, 10,000 sorry 1010 adults. Okay, among them 140 had experience, which means 140 successes. Okay, x equals 140, so your sample size is 1010. So simply you can calculate your p hat, x over n, so 0.14. Clear? Okay, now you have to check this assumption. Okay, please don't forget to do that. Okay, so when you plug the values for simple n and p hat, you have simple n here, here, p hat here. So plug those values and check whether our question is valid. Okay, here they have done it for you. Then next step, find the significant level. Last page I showed you guys how we find the significant level. They have given confidence level 90%, which means 0.9. So 1 minus 0.9 is your alpha. Alpha is 0.1 here. So you have to take the alpha over 2. Alpha over 2 is 0.05. Okay, then go to the C table and find C alpha over 2, which means 1.645. Okay, okay, then calculate your margin of error E by plugging the values to this formula. So you know what is C alpha over 2, you know what is P hat, you know what is N, then you can calculate error, margin of error. So next step, lower bound P hat minus E is this one, upper bound P hat plus E. is 0.16. So 95 confidence interval within these two values, lower bound comma upper bound. Okay, then at the end you should write your interpretation. We are 95 confidence. Okay, sorry, this should be 90. Okay, this should be 90. Why 90? They have given 90, not 95. Sorry for that. So we are 90% confident that what they ask, proportion of US adults who experience death of family members within last 10 years lies in between the values. You figure it out. Okay, 0.12 and 0.16, lower value and upper value. Okay. Okay, uh, margin of error. You know, this is the margin of error. At the same time, let's say you don't know what is the margin of error, but you can replace this margin of error using upper bound and lower bound. Okay, like I mean, if you need to find the length of confidence interval, if you need to find the length of uh, confidence interval, it's not like replace what I told you, it's not the replace. If you need to find the length of confidence interval, it is equals to 2 times margin of error, which means the gap between this error. Okay, this length is the length of confidence interval, the width in this interval. So if you don't know what is the margin error, as I mentioned before, if you don't know what is the margin of error, you can replace this 2 times margin of error by using upper bound minus lower bound, which means this gap. Okay, clear? If you don't know what is the margin of error, to find the length of the confidence interval, you can simply get the length of the confidence interval using the gap between upper bound and lower bound, upper bound minus lower bound. Okay. Okay, there is another problem type we can see in this population proportion stuff. It is how to find the sample size. They will give you different margin of errors, those values, and you need to figure it out what is the best sample size. If we need this much error, if we need this much margin of error, what is my sample size? So something like that. Okay, so only thing is you should remember, not remember actually, you should know this formula, and your answer at the end, your answer, please round it up. Okay, because sample size, there are no decimal numbers like 5.5, 5.3. No, it should be round up like 6. Okay, so anytime if you have to find sample size, round it up, use this formula and round it up. Okay, so when you're going to find the sample size, you should know what is p hat. It is sample proportion. E is the margin error, alpha is the significant level. Okay, just use this formula. Okay, I think there are a few notes about this formula. How do we find the sample size under given conditions? P hat value is, most of the time P hat value is provided, no problem, P hat is given. Okay, if no P hat value is given, then use this default value, P hat equals 0.5. If in the question they haven't mentioned what is P hat, please be noted that you have to use P hat equals 0.5, 1/2. Okay, if the range of possible P values or P hat values is provided, use the value in the range that is close to 0.5. If they have mentioned possible P values like, possible P hat values like this, these are the P hat values, and let's say this is your 0.5, So pick the closest one. If it is here, then pick the closest one. Okay, that's how we find the p hat value. If they have given, no problem, you can use it. If they haven't, use it as 0.5, or if they have given possible p hat values, few values, get the closest value to 0.5. Okay, okay, let's see how we gonna do this kind of problem. In this problem they have given, okay, margin of error, they have given capital E, they have given capital E 0.02, and they have given confidence interval. You can find alpha using 1 minus 0.95. Okay, making a guess for the observed value for p hat. P hat you need to guess, they haven't mentioned. If they haven't mentioned, what are the things you have to follow? These two. But here in our case, this one, no, they haven't mentioned any p value, so only way is this one. Okay, so we have to guess p hat equals to 0.5. Okay, okay, how we solve? Get the formula, this is your formula, and plug the values. You know what is alpha, this is alpha 0.05. So C alpha over 2 is 1.96. E they have given 0.02. Plug the values. Sorry, I forgot it. P hat 0.5. You guess it. Okay. So plug the values and round it up. I think this is 200. Sorry, 2,400.7 or something like that. So round it up. Okay. Clear? Okay. This is the sample size. So we need to find the sample size. That will ensure a margin of error of at most 0.02. Okay, so we have done. If we get this sample size, we can stick to margin error 0.02. Yes. Okay, that's the end of this chapter, end of this section 11.1, and I hope you guys get a better idea how we use this population proportion, or uh, go through it like population, not the population, sample proportion. So if you don't understand anything, please go again through these materials and make sure you are up to date. Okay. Okay, then that's all about the section 11.1. Then have a great day and see you another lesson. Okay, see you guys.